Okay, here I'm going to walk you through equation 510 for determining the standard uncertainty in the x-intercept with the Linus equation. So let's say we have some x and y data. We're going to do a linear regression of this and use the x-intercept. So of course the first thing we'll always do is plot it. Okay, there's our data. I'm going to remove the grid lines, and then I'm going to add a trend line. And we're going to look at the equation on the chart, and then I'm going to extend this line backwards 10 periods to see the intercept. The intercept somewhere between 0 and -5. So at least we'll know if we're getting a correct answer shortly. Okay, so what we're going to use once again is the Linus function for this. Here's our equation here, but we'll just read it off the Linus. Known y's, comma, known x's, true, comma, true. And then highlight 8 cells, click in the upper cell, Control-Shift-Enter, boom. We're only cells we're going to use are the slope, the intercept, and the error in y. And so, of course, we're going to want to figure out what this intercept is. And, of course, the intercept is when y equals 0, so 0 equals mx plus b. So it's basically just going to be minus b divided by m. So our intercept's minus 1.6, which really jives wherever this is pointing, so we know we got something right. So now we're just going to use this equation, which is very similar to 427. It's missing the y component up in the numerator here, and that's because we're extrapolating, we're no longer interpolating. It also is 1 over k, because it's not a single measurement. We're actually using this to actually look at an exact measurement, which is 0, right? Because we know we want the 0 value when that has no error. And so here we are. We're just going to calculate this, but of course, once again, it's good to have some measurements pre-done to make it easier to determine what these values are. So this is going to be my average y value. This is going to be my dev squared of x. And this is just how many I have, my count. Okay, so let's solve for this equation. What's my error going to be? My error is going to be my error in y divided by the absolute value of m. That is going to be added to, multiplied by the square root. And I'm going to just push this out a ways. So here's my entire square root value will be in here. In here I have 1 over my n. Yeah, I just want a space. Plus. Okay, now I have my division here. And the thing is this is where you guys keep getting nailed with your order of operations. So I'm going to put 2 parentheses here to delineate the fact that I have this is everything in here will be this fraction, and in fact I'm going to put another set in here. So everything in here will be on top, divided by everything between these two are on the bottom. Okay, so what's on top? Well, what's on top is very small. It's just this y squared. Okay, pretty easy. What do we have on the bottom? Well, we have an m squared, and that's multiplied by my dev squared. Okay, there's my error. Okay, just make sure these two match when you round your values to report, and that's it.